Okay, today we're going to be discussing slopes of lines. You'll find this in your textbook, Chapter 3, Lesson 3. This is something that we've discussed before in Algebra 1, so it should be pretty familiar for you. Our mathematical practices, we've got three different mathematical practices that we'll be working with today. Previously, you've used the properties of parallel lines to determine congruent angles. And now we're going to find slopes of lines, and we're going to use slope to identify parallel and perpendicular lines. We only have two new vocabulary words, which aren't so new: slope, and rate of change may be something a little different. It's another term for slope when it's not the same all the way across the line, when we take the average. Okay, key concept, the slope of a line. So if we're looking in the coordinate plane, the slope is the rise over the run. And so we've got a formula to find slope. It's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We also call it the differences in the y's over the difference in the x's. So whichever way is more convenient for you to remember it. Now we're going to find the slope of the line. The first thing you need to do is pick 2 points that are on the line. You want not just any 2 points. This one, is going to be a fractional part or decimal. So you want to pick 2 points where it's actually at an intersection, so you can determine the ordered pair. On this situation, they're choosing -3, 7 for point 1 and -1, -1 for point 2. You just substitute it into the slope formula. One thing to note, if you're using y1, if you use y2 first minus y1, then you have to use x2 minus x1, and it doesn't matter. You can use y1 minus y2 as long as you use x1 minus x2. So it doesn't matter which point you name 1 or which point you name 2. You're still going to get the same answer. The slope is -8 over 2, which is simply -4. Find the slope of this line. So we've got 2 points here. We're going to use 0, 4 and 0, -3. Substitute into the formula. -7 over 0. So can you tell me what that's going to be? This slope is undefined. You cannot divide by 0. So whenever you see a straight vertical line like this, you know that that slope is undefined. It has no slope. You cannot define it. Okay, find the slope of this line. They've picked 2 points, apparently F and G. -2, -5, and 6, 2. Again, it doesn't matter which one you call point 1, which one you call point 2. So don't spend time fretting over that. 7/8. You can check your answer by looking at the graph. If it goes up 7 over 8, you know you've got the right slope. Oh, slope of this line. We've got a horizontal line. We picked 2 points, -2, -1, and 6, -1. Substitute into the equation. 0 over 8. Now we can take 0 and divide it by 8. The answer is 0. This one has a 0 slope. Okay, time to check your progress. So as I select each one, pause the video and work the problem. Select your answer, then come back to check to see if you're right. You get an answer -3/5. Good job. Find the slope of this line. Do you really need to do the work? We know a horizontal line has a slope of 0. How about this one? Has a slope of 2, +2. And finally this one. If you remember from the video, when you have a vertical line, it is undefined. Excellent. So in a nutshell, classifying slopes, if you put your car on this line going left to right, it goes uphill, that's positive. Car going left to right, it goes downhill, that's a negative slope. This has a slope of 0. Any horizontal line has a slope of 0, and any vertical line has an undefined slope because you're dividing by 0, and you cannot do that. So if you want to take a moment and pause the video and put this in your notes, that would be an excellent idea. Now, slope can be interpreted as a rate of change, describing how a quantity y changes in relation to quantity x. The slope of a line can also be used to identify the coordinates of any point on the line. You might take a note of the keywords in this problem. In 2000, the annual sales was 48.9 million. In 2005, 85.9 million. If the sales increase at the same rate, that's why we're using rate of change, what will be the total sales in 2015? So they plotted the 2 points, 0 and 48.9, and then 5 years later it was 85.9. What will it be in 2015? Notice we're looking at how long, the years since 2000. So the difference in the slope for the line is 7.4. So if we have that same slope of 7.4, what will it be in 2015, or 15 years from 2000? We simplify, multiply each side by 15, and add 48.9 to each side. So in 2015, it's estimated that sales will be about 159.9 million. So from the graph, you can estimate that in 2015, the sales will be a little more than 150 million. Since 159.9 is close to 150, our answer is reasonable. Okay, time to check your progress. So pause the video for a moment and check your answer. So when I set up the equation, I took my average rate of change, 14.2. That's my slope. I set it equal to y sub 2 minus 109.5 over 10, because it's 10 is 2000 to 2010 is 10 years. Multiply both sides by 10, add 109.5, and you get 251.5 million. Now there's some postulates about parallel and perpendicular lines. If you've got two non-vertical lines, notice these aren't straight vertical, and they have the same slope, they have the same slope if and only if they're parallel. So all vertical lines are parallel. Now two non-vertical lines are perpendicular if and only if the product of their slopes is -1. So if one line has a slope of 4 and the other one -1/4, if you multiply those two together, they come up to a -1. I also call this the opposite reciprocal. This one's positive, so the opposite is negative. This is 4 over 1, this is 1 over 4. So your slopes for perpendicular lines will be opposite reciprocals. We're determine whether line FG and HJ are parallel, perpendicular, or neither. So we're going to look at FG and find the slope of that line. We're going to look at HJ and find the slope of that line, and we're going to compare the slopes. So the slope of FG is -2/3. The slope of HJ is 3. So are they the same slope? No. Are they opposite reciprocals? No, because they'd have to be a positive 3/2. So this one is neither. And when you graph it, you can see that they don't intersect at right angles and they're not parallel. That's a good way to check your answer. Just graph them. Okay, time to check your progress. So pause the video for a moment. Find the slopes of these two lines and tell me, are they parallel, perpendicular, or neither? Well, you came up with slopes that are opposite reciprocals, so they are perpendicular. Now we're going to use slope to graph a line. They want us to graph a line that goes through this point 5, 1, and that's parallel to line MN. So the first thing you need to do is find out what that slope is. We're going to use the slope formula, substitute in the 2 points. So the slope for MN is -3/4. So we need a line that has a slope of -3/4 that goes through 5, 1. The first thing you want to do is graph the original line that goes through those 2 original points and put a point at 5, 1. Now we're going to use the slope -3/4. So you can go up 3, left 4, up 3, left 4, and graph the point R. Connect your points, and you've got your line. Okay, so time to graph the line that contains 2, -1, and it's parallel to line OP. So which one of these would it be? Pause the video for a moment and check your answer to see. Very good. The answer is A. Excellent job, folks. You are now ready to begin your exercises.